Okay, so we have a set of numbers here, a set of x, y points, and the question is this a function? Okay, so if it's not a function, what would it be? Well, it would be a relation. I'm going to go ahead and cover the basics of relations and functions here in a second, but there's a number of different ways we can kind of approach this particular problem to answer it. Okay, so it's either a function or not a function, hence it would be just a relation. So if you know how to go ahead and answer this and use your whatever particular method comes to mind, but again, there's not just one single way to answer this question. Of course, there's only one right answer. So go ahead and put your responses in the comment section. If you know whether this is a function, go ahead and support it, support your reason, okay? And if it's not a function, support that reason as well, okay? Yes or no is not going to be good enough. So if this is, for example, a test question, I said, is this a function? And you said, yes. Well, you're not going to get much points because you got to justify this response. And that's what this whole little video is going to be about. So we're going to cover the basics of how to determine whether something is a function or not. Okay, but I'm going to get to all this in just one second. But first, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher. I'm going to leave a link to my math help program in the description of this video. But basically, I have 100 plus different math courses ranging from pre-algebra to pre-calculus and everything in between. So if you're at the middle school, high school, or even college level in terms of mathematics, I can help you excel in your math courses. Now, if you're taking any test that's going to have math on it, so I'm talking about things like the GED, SAT, ACT, ASVAB, AccuPlacer, ALEX exam, GRE, GMAT, CLEP exam, teacher certification exam. There's a ton of exams that people take out there for multiple different reasons, and there's always this little math section on there. I can help you prepare and pass those tests. If you homeschool, you definitely got to check out my homeschool math program. Very comprehensive, have a great track record there. Now, if you don't have any math notes, well, you need something to study from. So what are you going to study from if you don't have any math notes? You can use my math notes. I'm going to leave links to my math notes in the description of this video, but I've been teaching math for decades, and most students really, truly underestimate how important it is to take great math notes. So start taking excellent math notes, and you'll see that your grades are just going to skyrocket. All right, so let's go ahead and get into this problem. Again, you can pause the video and study this for a moment and use whatever technique comes to mind to answer this question. I'm not going to cover all the techniques here. I'm going to show you one particular one that is pretty common when we're dealing with functions in this kind of form. But let's just kind of get a bigger picture of what's going on. Okay, so we have this whole gigantic world out there of that's called relations. Okay, so what is a in mathematics? What is a relation? Well, it's simply just an XY point. Okay, so here's a little XY axis right here. Okay, coordinate plane, and so we have some point out here. Let's call that 2, 4. So that is a point that is on the XY plane. So a relation is basically just a collection of these points. Okay, so you're going to have one or more of these points. So if you have a set or a collection of points or ordered pairs, that effectively is a relation. Now, of course, we can have all sorts of collections of points. So, for example, a line. Here's a line, right? Graphically, you're like, well, that's not a point. Well, there's an infinite amount of points on this line. So this line represents all the infinite amounts of points that represent the sets of all the points that are on this line. So you can see when we're talking about relations, they can be expressed this way, or they can be expressed kind of graphically because there are a collection of points on there. So just want to make that clear. Now, in the world of functions, okay, functions are a particular type of relation. So in this whole world of relations, some of these are functions, okay? So what we have here in this particular problem is a collection of xy points. Okay, so this is an xy point here, just so there's no confusion here. This is another xy point. So this is, you can see by definition, a relation. It's definitely a relation, but is this a function? Well, that's the whole question. So functions are relations, okay? But they also follow a very specific definition, okay? There's kind of specific conditions. Now, why do we care if something is a function and not a relation? Well, if something is a function, that gives us a whole nother set of aspects in terms of what we know about something in mathematics. Okay, so functions have very unique properties about them. And when you study things like in algebra, you'll hear this word functions all the time: quadratic functions, polynomial functions, rational functions. This word has a very precise and specific meaning. So what we're going to do is go through a test here, okay, that is going to determine whether a relation is a function. Okay, so if it's not a function, it's just obviously just a relation. So all functions are relations. Some relations are functions, just to be clear on that. Okay, so let's get into how I'm going to determine whether this is a function or not. Of course, we're going to have to understand the definition of a function, and I'm going to explain this here in a second. But what we're looking at is what we call a mapping diagram. Okay, this is an excellent way to determine whether a collection of points is in fact a function or just a relation. Now, oftentimes you'll be given a mapping diagram. They'll just be given this stuff, and basically they're basically two ellipses, something like this, and then there's values in here, and there's arrows pointing from the left to right. So I'm going to explain this mapping diagram, and then we're going to answer this question. So what we have here, this ellipse over here is going to be all our x values of these points. So let's just take this first point here, 1, 2. What is the x coordinate of that ordered pair? It's 1. And then the y coordinate for that ordered pair is 2. Okay, so that's 1, 2. It's x, y. It's an ordered pair. There's a specific order, x first, then y second. So this is a point. So we're going to put all our x's over here in this first one. Okay, all these values right there. These are all of our x's. Okay, and then we're going to put all of our y's, our respective y's, in this little ellipse right here. So I'm going to show you how this works if you're not familiar with a mapping diagram. This is really, really important. Okay, so you can see here that I kind of have this already started. So let's just take a look at all of our x coordinates here. So we have 1, we have 3, we have 1 again, we have 5, and we have 2. So you want to put these in order. So it's going. I want to start with 1, and then 2, 3, and let's see here. Do we have 4? No, we don't have 4. Okay, so we don't need this 4 right there. So let me just start from the beginning. So we have 1. All right, so we're looking through here. Oh, we have a 2. We'll put that in there. We have a 3. We don't have a 4, so we have a 5. Okay, so these are all our x values. Now, how does this work? Well, let's go ahead and start with our first point, okay? So this is 1, 2. So this x, this 1, goes to 2, all right? So in our y ellipse over here, we're going to put a 2, and then we're going to draw an arrow from 1 to 2, just like this, okay? From 1 to 2, from the x to the y, okay? Just like that. Okay, now why that is, that's a whole nother little conversation. Just know this is the way we do this. Now this 1, 2 represents the point 1, 2, whoop, not 1, 12, write this better, 1, 2. All right, so let's move on. That's that point. Let's keep this in order. Let's go to where we have a 2 and a 1. Okay, so 2 is going to map to 1. So we need a little 1 over here. Don't worry about the order of these things. You'll see here in a second how this works. So but just know that 2 maps to 1, and that represents the point 2, 1. Okay, so that's that point. Let's move on to 3, 5. So 3 is going to map to 5. All right, so 3 maps to 5. Again, this represents the point or the order pair 3, 5. And then we have 5 maps to 9. Okay, so we'll put a little 9 right there. And then we'll draw an arrow from 5 to 9. Okay, so 5 maps to 9. And then we're left with 1 maps to 4. Now, let's take a look at this situation. So I could write it like this. Most of you would be like, okay, 1 maps to 4. Should we do it this way? 1 maps to 4? Well, no. Okay, that's not the way you do it. So the way a mapping diagram works is if you already have that number written already in the slips, you don't rewrite the same number twice. In other words, I already have 1. I don't need to write another 1 over here. And if I had 4 over here, if I already wrote it for another value, another point, you just leave it. So we already have 1, okay, but I don't have 4. So let's put in a 4. Let's put in a 4 right here. We'll squeeze that in right there. Okay, let me just draw that a little bit better. 1, 4. Now, I specifically left this point last, okay? So 1 maps to 4 would go like this. 1 is mapping to 4. So that represents the point. Let's put this up here. 1, 2, and then we have 1, 4. Okay, so we're done constructing our mapping diagram, but my question to you is, can you interpret this, whether this is a function or not? Well, hopefully you know the answer to this, because this is not a function, not a function. So why is it not a function? Well, the definition of a function, and there's a lot of different ways we kind of think about the definition, but effectively it's this. For every x value, okay, there's only one and only one y value. So in other words, each x value here can only point to one y value. So you can see 1 is trying to point to 2 and 4, okay? This fails the definition of a function. So a function is every x has one and only one unique y. Okay, so if you see this kind of split from an x to going to 2 or more different y's, that is not a function. Okay, so let's go ahead and do something interesting here. Let me let's kind of play around with this in this, just so we can kind of further look at this. Let's erase these points here. And let's say you had a mapping diagram like so. Okay, so we're just going to make something up here. Let's say we have 1 maps to 1 and 2 maps to 2. Okay, now let's do something a little bit different here. 2 maps to 9. Okay, and then we had 3 maps to 9 and then 5 maps to 2. Okay, now is this a function? Okay, is this a function? So we're going to practice interpreting these mapping diagrams. So a lot of you are probably going to say, no, this is not a function, because look, you have 2 arrows pointing to the same number. Well, this is a function. You're going to say, wait, what are you talking about? It's the x. Does every x go to point to 1 and only one y? That's the test here. So 1 is pointing only to 1, so that is okay. Okay, so let's take 2 now. Okay, so 1 is good. Does 2 point to only one value? Well, 2 points to 9, so that's good. Okay, does 3 point to one value? Yes, it points to 9. But hey, wait a minute, 2 and 9 are pointing to the same number. That's okay. Okay, that is okay. So right here, this is not an issue, okay? And then, of course, 5 points to one number, 2. So this represents a function. And, of course, you could see this if I had a collection of points. This would be what? The point 1, 1 right here. And then this would be 2, 9. Okay, 2, 9. And then we would have 3, 9. All right, that would be our another point. And then we would have, what? 5, 2. Okay, so 5, 2. So using a mapping diagram is excellent, but of course you have to know how to interpret it. Now, if I had, let's say this, okay, and let's go ahead and break this thing. Let's say we did have 2, 1, and oftentimes you'll see something like this. So it gets a little confusing. So your teachers are trying to trick you. You're like, okay, 1 is going to 1. Oh, look, 2 is trying to split off to 2 different numbers. Okay, this x is trying to pair it with 2 different y's. This fails the definition of a function. So again, there's different ways we can look at this in terms of interpreting whether this is a function or not. You can look at this even graphically and see if it passes the vertical line test. But really, the whole point of this video is using a mapping diagram, because this is pretty common in algebra and how you can construct it. But the main idea is this: a function is a set of ordered pairs, a set of points, i.e. a relation, such that every x points to only one and only one y. Okay, and we can construct a mapping diagram to kind of see what's going on. Now, some of you can kind of visually look at it, but I'm telling you right now, it's easier to put this into a mapping diagram because you're going to be asked to interpret different mapping diagrams when you study algebra. Now, here's the one thing. Let's just go ahead and just give you one last piece of information here. Let me go ahead and erase this and fix this up. So 1 is 1, and let's say 5 maps to 2. Okay, so this is our function. Okay, so now we determine that this is a function. All the set of x's here, this is called the domain. Okay, domain. All right, so the domain represents all the input numbers. Our x values are our input. Okay, so this is a little additional piece of information you want to know about functions. So the collection or the set of all of our input values, which is associated with the x value, it's also called the independent variable. Okay, all these x values right here is called the domain of this function. Now, all these y values here, the respective y values, is called the range. Okay, and of course, this is our output value. So this is our dependent. So y is dependent on x. That's why this arrow is going from x to y. All right. So this is our independent variable, and this is our dependent variable. So more additional things to learn about functions. Functions is a huge topic. So much to learn about functions. You know, these terminologies in terms of domain, range, independent variable, dependent variable, you know, and how to interpret functions. This is the kind of the beginning of it. So if you understand this, well, then you're well on your way to understanding, you know, much more about functions. And you absolutely need to know about functions to be successful in algebra. I have tons of videos on this, by the way, in my algebra, pre-algebra playlist. So you can check out a lot of different videos I have, you know, again, on function topics, but it's quite extensive subject, okay? So you're gonna just have to take it one piece at a time. But if this little video was helpful, please go ahead and consider smashing that like button. That definitely helps me out. And if you're new to my YouTube channel, hopefully you'll consider subscribing. I've been on YouTube for 10 plus years, have over 1,000 plus math videos, basic to advanced mathematics. So, you know, if you like my teaching style, there's a ton of content there. Of course, my best stuff will always be within my math help program. So if you want to know more about functions, I would encourage you to check out any one of my algebra courses. Pre-algebra, I teach it. Algebra, I teach it at a more advanced level. Algebra 2, it's even a little bit more advanced level. And then, of course, in my pre-calculus course, we get really, really advanced into functions. So wherever you're at, you know, functions will always be part of your education, your math education, especially at the high school and college level. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.